Welcome back to the Deep Dive. We're here to pull out the key nuggets of knowledge from the latest research, just for you. Today, we're stepping into, well, a really interesting shift in software development. Some people are calling it the age of vibe coding. Now, that's not just some catchy phrase. It really points to a big change, where generative AI is moving us away from typing every single line of code ourselves. Instead, we're shifting towards supervising these powerful AI actions. It's kind of about trusting the AI with the routine stuff, letting developers focus more on the bigger picture, the problem solving, the sort of vibe of the code. And in theory, this should make programming easier to get into for everyone. But as tools like GitHub Copilot become more common, there's a really important question. How do these advances specifically affect screen reader users? They're a vital part of the programming community. So our mission today is to dig into a recent, pretty rigorous study that looked exactly at this. It focused on screen reader users and their experiences with these advanced AI code assistants. We'll explore the huge value they offer, definitely, but also some surprising new challenges that popped up. This is for you, whether you're a dev and accessibility advocate or just curious about where human-AI interaction is heading.
Yeah, and what's really fascinating about this study is how deep it went.
Yeah.
It wasn't just a quick snapshot, a one-off survey. This was a 2-week, 3-phase longitudinal study. They worked with 16 screen reader users over time. And the goal wasn't just looking at basic code completion. It was designed to really understand how people practically used these advanced AI tools in their day-to-day work over that extended period, that kind of long-term research. It's absolutely crucial. It helps us see how people actually adapt and gets us beyond just first impressions. It's about filling in those knowledge gaps, moving past anecdotes to real data on this evolving accessibility landscape.
That makes sense. You need that longer view to see past the novelty, right? To see the real sustained impact. And speaking of impact, let's start with the positives. Because the study did find that these AI tools aren't just helping a little, they're actively empowering screen reader users in some pretty significant ways. What really stood out to the researchers, beyond just making things faster,
Well, the key thing, I think, is that these AI assistants are kind of democratizing programming. They're opening up areas that were really, really difficult for screen reader users before, especially things that rely heavily on visual layout. Take UI development, for example. That's notoriously visual, incredibly challenging if you can't see the screen easily. But this study showed AI assistants can make it much more doable. There was one participant, P10, he mostly did back-end work because of his visual impairment. But he used Copilot for UI tasks. He talked about taking user feedback about the UI, turning that into prompts for Copilot, getting it to generate or change code, and then checking screenshots with a sighted colleague. He said Copilot could generate a usable interface, maybe basic visually, but functional. It really simplified things for him. Like, he used to spend so much mental energy just trying to stop UI elements from overlapping. Copilot basically took that specific worry off his plate.
Wow. Okay, so it's not just that they can do UI now, but that cognitive load, that mental energy you mentioned, is actually reduced. That's huge.
Exactly. And that reduction in cognitive load wasn't just for UI. Across the board, participants reported clear benefits. They were more efficient, their programming skills improved, and crucially, it lowered the barrier for learning new technologies. Participant P13 put it really well, saying something like, with a code assistant like this, it's much easier to get started with programming. It points to this fundamental shift, You move from painstakingly executing every task yourself to supervising the AI. And participants found that really empowering, kind of liberating. It makes programming feel less like a solo visual task and more like a collaboration with an intelligent partner.
That really does sound like a paradigm shift, making parts of programming accessible that maybe weren't before. But like with any powerful new tech, there are usually new complexities too, right? Despite all these benefits, this study also found some pretty significant new hurdles. So what does that look like day to day? What are these new complexities screen reader users are facing with these advanced AI tools?
Right. The challenges are definitely there, and they're quite nuanced. Users basically have to develop whole new ways of interacting. The study highlighted issues in 3 main areas. First, just communicating with the AI. That turned out to be harder than you might think. The AI is powerful, sure, but getting your intent across clearly can be a bottleneck. Users need to become pretty good prompt engineers, essentially. They struggled to phrase prompts effectively, too short, and the AI might make wrong assumptions. P4, for instance, used a simple prompt like check for errors. But Copilot then suggested changing calculation rules that were specifically not supposed to be changed according to the documentation. Unexpected, right?
Yeah, that could cause real problems.
Definitely. And then there are issues with keyboard shortcuts. They're meant to help, but inconsistencies or conflicts with existing screen reader habits caused a lot of frustration. Like the up and down arrow keys in the input box sometimes cycle through past commands instead of moving line by line in a multi-line prompt. Little things like that. Or Create-Chihuahua plus Enter doing different things depending on context, accepting code in chat, but opening suggestions in the editor. That confused users like P2 would be like, wait, where am I? How do I get out of this? There was also just not enough feedback sometimes about the session settings, the mode, the AI model being used, the context files. Users like P11 had to take extra steps just to check, so people developed workarounds. P8 started writing these super detailed step-by-step prompts, things like do not modify the code yet, then okay, now make changes step by step just to keep control.
That really highlights a kind of control challenge, doesn't it? They have to manage the AI almost as much as they manage the code. Which makes me think about the next step, reviewing what the AI actually generates. If just telling it what to do is tricky, checking its work must be tough too.
Oh, absolutely. Reviewing was singled out as the most time-consuming part. On average, it took nearly 12 minutes per interaction. Users had real trouble tracking complex changes the AI made or just navigating multiple suggestions effectively. The tool had sound cues, ear cons for changes. Some people, like P13, found them helpful, appreciating feedback beyond just text, but others, like P7 and P5, found them confusing or hard to tell apart. They wished for clearer verbal explanations instead.
So even the accessibility features had mixed results.
Exactly. And the ways to view the information had pros and cons too. The structured message list was good for some, like P10 for navigating, but for others, like P5, who didn't like switching screen reader modes, browsing linearly through long replies, especially in the more automated agent mode, made it really hard to quickly grasp complex stuff. Then there was the accessible view. Simpler, yes, but often less detailed. P5 noted it might say a file changed, but not which one. And critically, it didn't update automatically. You had to manually refresh it, which P2 and P7 found annoying. And a huge issue here, model hallucinations. The AI would sometimes just make things up. Incorrect info, fabricated results, but presented confidently. Or it would only do part of a task but not say so. This really eroded trust for users like P12, P6, and P2. They ended up spending way more time double-checking everything.
Wow. So the AI saves time on one hand, but then you lose time verifying its work because you can't fully trust it. That's a tough trade-off.
Yeah.
And it sounds like juggling all these different parts, the chat, the code, the output, adds another layer of difficulty.
That brings us to the third challenge, switching between views and maintaining situational awareness. How did that play out?
Yeah, this was a big one. Keeping track of where the focus was, editor, chat panel, integrated terminal was consistently difficult, especially in that highly automated agent mode. P7 sometimes lost track and ended up typing in the code file when they meant to type in the chat. P4 talked about confusing focus jumps in inline chat that broke their flow. And the agent mode's use of a built-in terminal added more complexity. A lot of participants actually preferred using their own external terminal because they worried about getting trapped, focus-wise, in the integrated one. P15 had a situation where the chat said everything worked, but the terminal, which was hard to get to, actually showed an error he only found later. P14 mentioned terminal output just wasn't announced clearly, so it was hard to know if a command even ran, let alone succeeded. So you're flying blind to some extent.
Pretty much. And verifying results across these different views was a real pain point. P3 and P8 tried to get Copilot to use terminal output to fill in a report. Instead of using the real data, it inserted hallucinated data, just made stuff up, which led P8 to say, understandably frustrated, how can we verify it? It can lie. Finally, the status notifications from the AI itself were often unclear. Things like working or progress. Okay, but what does that mean? Does it need input? P4 often asked, do I need to execute the command now? P3 even joked that the interviewer was their accessibility feature because they needed constant clarification. Although on the flip side, P14 and P5 pointed out that too much notification, especially verbose ones, could also be really distracting if they were trying to multitask.
That paints a really detailed picture. It's clear that while the potential is massive, the actual day-to-day experience for screen reader users right now involves navigating some serious complexities. So given all this, what are the bigger takeaways? And more importantly, what are the concrete design recommendations coming out of this research to make these AI tools truly work well for everyone?
Well, the implications are pretty significant, I think. They go beyond just fixing bugs in one tool. It's about fundamental principles for human-AI interaction. First, UI complexity and interaction consistency. The big recommendation here is keep it simple, predictable, and efficient. That means clear ways to move between different modes or views and making sure interactions are consistent, even if the AI is doing different kinds of things. Reduce that cognitive load we talked about. Make it easy to learn. Second, transparent status and better error handling. The tools absolutely need to give clear, real-time, non-visual feedback about what the AI is doing. Is it working? Waiting. Done. And critically robust ways to discover, understand, and recover from errors. That means things like a universal, accessible undo function and error messages that actually explain what went wrong and why, guiding the user. And third, the study really pushes us to think beyond just the tool's interface. Accessibility needs to be baked in from the start throughout the whole user journey. That means things like screen reader-specific documentation, tutorials, maybe even using AI itself to generate step-by-step help or answer questions about how to use features, addressing those learning hurdles. And if you connect this to the bigger picture, what this research really shows is something we often find. Making things more usable for screen reader users usually ends up making them better for everyone. It's not just about ticking an accessibility box. It drives better design overall.
That's a crucial point, so it's clear, isn't it? The power of AI in programming is undeniable. The potential is there. But making it truly inclusive means really understanding these detailed user experiences and designing thoughtfully. So what does this all mean for you listening right now? As this vibe coding idea becomes more mainstream, how do we make sure that empowering vibe reaches everyone, no matter how they use their tools? And maybe more importantly, what's your role? Whether you're building these tools, using them, or advocating for better ones, how can you help shape a future where accessibility isn't an add-on, but just part of how things are built? Something to think about.